Okay, everybody. So what we're going to be doing in this video is Lab 13. So Lab 13 has to do with methods, which we've been covering for a couple of weeks at this point, and in fact, we probably have moved on from that topic now. And so what we're going to be doing is basically implementing a method to do a math formula. That's actually very straightforward to do. So we'll go ahead and get started here. So looking at problem one, what problem one has to do with is if we have a triangle here, we could calculate the area of that triangle. And the normal formula that you'll find if you, dang it, can't just Alt Tab here. Why not? Okay, now I can. The normal formula that you'll find if you type in area of triangle is, of course, the one that you learn in elementary school, right? That the area of a triangle is the base times the height divided by 2, or normally written this way, area is 1/2 base times height. Um, but that only works if you know the height of the triangle. And over here, we have a triangle where we know the sides, the length of the sides, but we don't know the height. And so since you don't know the height, what would you use? Well, if you don't know the height, you can use what they call Heron's formula. So Heron's formula is what we're going to implement for problem one. And there's already some sample code down here. And so looking at the sample code, I see that the class is called Heron's. Okay. And then it says public static double calc Heron's. So this is the formula that we're going to write. And then in the main method, it's already done for us. So we have a scatter object. We have variables A, B, C, and area for, right, A, B, C for the sides of the triangle and the final area. And we tell the user to type in the sides of the triangle. First one is A, second one is B, third one is C. Then we're going to call this formula calc-Heron's, which we have to write. And then we're going to print out the result. And so all the code is written for us except this method, right? Which is what we're learning is methods. So um, to do this, if we go to Eclipse, we can go File, New, Java Project. I'll call it Lab 13. Um, in here, I don't have to do this, but I will. When I create my class, I'll call it Herons, capital H. Um, and I called it Herons with a capital H just so that it would match the one right here, right? Because this is class Herons. So then I can just copy paste this code in here to get started. So I'll just select everything, delete it, paste this, save it. Cool. So this does not run yet because we have to write this method. So looking at the method that we have the sides of the triangle come in, the A, the B, and the C, and they're going to be doubles. And the return type is a double because when we're done calculating the area, we need to return it, right? So like the last line of our problem, last line of our method is probably going to be like return area, right? Something like that makes sense. Of course, we have to write the rest of it. So looking at this formula, the way it works for Heron's formula is you have an A, a B, and a C, and we want to calculate the area, but you'll notice the area has this S in there as well. S, 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 S. So you have to calculate the S. So Heron's formula has this extra variable called S that's A, B, C, A plus B plus C, all divided by 2. So get started, we should just give ourselves some variables in S and the area. And then the S, I'm using lowercase variable names, should be, and it should be A plus B plus C over 2. So you just write that A plus B plus C divided by 2. You can put 2.0 if you want. So there we go. That's the S, right? A plus B plus C divided by 2. So that'll calculate this part of the formula. And then for the next part, we calculate the area, which is going to be the square root of all this stuff. So inside of the square root, we have S times S minus A. So that's like S times parentheses S minus A times S minus B times S minus C. So times S minus B times S minus C. That's all the inside. That's all the inside of this square root, but we still need to do the square root. So for the square root, before this, I will do math, capital M, dot square root, open some parentheses, put all this stuff in, and then at the end the parentheses. Now, sometimes what a lot of people would do, I shouldn't say a lot of people, what some people would do here is, if the line is a little complicated, has too much math in it, then sometimes what people will do is they will calculate something like this, S minus A, S minus B, S minus C, and then that's the inside of the square root, and then do the square root afterwards by doing something like area equals math dot sqrt area. If they get confused by the parentheses or something, it's all the same at the end of the day, right? We're gonna multiply these things together, and then we're gonna square root it, and then we return it. And that's all we had to do because the rest of the program was already written for us. So if we run this, it should just work. So actually, is there an example? Nope. Okay, well, we don't have a good way. I guess if we do area of a triangle and we look for an example, just grab, sure, if I do images, we'll find an example. Well, they don't have sides, right? Maybe we should type in herons. Just looking for numbers, guys. Okay, here's one. So we know that the side lengths are 20, 14, and 14, right? So let's try that. 20, 14, 14. And our answer is 97.98. And I look here and they have this. So I guess I still don't know if that was right, but it should be, right? I guess we could try it. Square root 9453.9. Don't know why it's doing that. 9453.9. Oh, I think it was like something like that. And we didn't type the whole thing in, right? Only I stopped after two decimal places, but this was 97.23, and that's close to what we got. So that's probably right. So everything seems fine there. And that's it. We did it. So we calculated the area of a triangle using Heron's formula. Okay. Now going back to our lab, the second problem has us doing the exact same thing, except this time we're calculating the volume of a pyramid with a hexagonal base, right? Sounds complicated, but the thing is that we're not really thinking about what the formula should be for this, right? We don't have to because the formula for this is printed right here, right? You're going to input the base and you're going to input the height, and then we plug them into the formula, and it's just going to calculate the volume. So really, this is very similar to the previous problem. It's just that it needs to be modified for this case, right? So what I would recommend that we do this for this is that we create a new class. We could do it in the same project, or we can make a new project. So maybe new class, and I'll call this just hexagonal. Okay, sure. So I called it hexagonal. And we've got nothing in here now. And to reuse as much work as possible, I'm just going to go to Heron's formula. I'm going to copy paste this entire thing. I don't know why. Like when I'm doing Control A to select everything, it's not showing up. I don't know why. But I did copy it and I pasted it. Now, what do we have to change? Well, many things. So if I just copied that problem, first of all, the class name is hexagonal, so I have to change the class name here to hexagonal. Hexagonal. Okay, so now that's right. This is all going to be wrong, so I'm going to delete the inside there. But then let's go down to the main. And so what this has is we need a base and a height. We should probably call those B and H, right? A base, a height, and a volume. So um, I'll get rid of these variables here and have a B and an H and a volume, right? Something like that. They all could have been on the same line. They don't need to be separated like this. And then these prompts are a little bit wrong too, right? So we could say enter the length of the base B, right? And then change this to get the number B in there. And then the next one could be enter the length of the, what was it? Was it height? Yeah, it was height. So it's not actually length. Enter the height, H. And then we could read in the variable H. We don't have a third thing to input, so we can just delete that. Then it says now call calc herons, but this is wrong because we're not calculating an area, we're calculating a volume, so change that. And we probably don't want to call it herons. We call it maybe calc hex. I'll just call it calc hex. And what has to go into it are not A, B, and C, but we need a B and an H, right? Then to display our answer, we should say the volume is volume. Okay, so we've redone our main to be our variables. Mostly we just edited the lines that were already there. We didn't really have to write any more because it was quite similar to the previous one. However, we do have to write this calc hex now. So we can go up to calc herons, change it to say calc hex. Um, I think maybe I said to call it calc volume or something. Yeah, I did, but it doesn't matter. We'll call it calc hex. We need the B and the H to come in, so that needs to be double B, comma, double H for the inputs. The output is still a double, so we're good here. And now we just need to make sure we calculate the volume. So I should probably declare the volume to be a variable. It's declared down here, right? But every method has its own local variables. So this volume is a different volume. And then we can do volume equals, and we just need this formula. So you have to be careful how you type this. So we need a square root of 3 divided by 2. So that would be math.sqrt for the square root 3. Be careful to put the divided by 2 on the outside, right? Because the square root is only on the 3. The 2 is not part of the square root. Neither is the rest of it. Only in the 3 is in the square root. So square root of 3 divided by 2 times, and then we have b squared, oops, which I will type in as b times b, and then h times h. There we go. And then we just need to return the volume. And we should be good. Everything should be fine now. We got our formula just straight from the lab manual, the lab page. All right. Looking at problem 3 here, it says show the results of problem 1 using 5, 6, 7. I'm not going to do that. You could do that. 3b says show the results of problem 2 using b equals 3, h equals 10. So b equals 3, h equals 10. I can remember that. So let's run it. Enter the length of base b, 3. Enter the height h, 10. Enter. 77.942. So Apparently, that's the volume. Okay, so you need to screenshot those or show the results of those. Sometimes what people have been doing, and this is kind of sufficient if you really want to, is if you don't want to screenshot that, you could copy the output here. And in here, right, you should have your name and everything in here. So it should be like, right, you have that. If you want, you can go ahead and put just like your kind of output in there if you feel like it in a comment. Um, all right. So anyway, we did the whole thing except for 3A here, but 3A is just running the problem one with these values instead of the values that I ran it with. So I think that's it. So lab is short and sweet. Um, I'll see you in the next video, which will be lab 13B.